but it was kind of wrong, so it needed updating. And also, obviously, if you don't work on something, it's not going to get updated on its own, and it's not going to, get there with explaining more things and being more correct, and including more explanations. For example, explaining all the different types of particles and particle states and quantum properties like spin, etc. So basically, taking all that and then giving it more sort of an extension is what will be happening now. But that's the base of it. The base is what we just discussed. The base and the foundation is that general relativity allows you to incorporate extra dimensions, and Kaluza and Klein were bold enough to do that in the year 1919, and even it was published in 1921, and Einstein gave it a look, thought about it, could not really find mistakes, but or really something wrong with it conceptually, but it did not have experimental success. Now, when a theory does not have experimental success, doesn't mean that it's instantly wrong. It means that it needs more work, it needs to be updated, and it needs to be refined with experimental support, right? And the theory and the experiment should be supporting each other and working with each other. Of course, they have to get along in order to do that. Usually the theorists are not the same people who design and build and run the experiments. So they have to get along and they have to work together. But without that too, the theory will kind of die, right? And that's exactly what it did. It did die until it was time for it to be kind of revived again, which is what's going to happen in the 1960s, which is what we'll talk about next. Does gravity have any effect on the microparticle field? On the microparticle field? Well, gravitation will work on anything that has mass. So all of the particles that are massive are affected by gravitation, and in fact, light is even affected by gravitation. So depending on if your gravitational field is very strong, even light will be bent. So yes, I think I'm not exactly sure what you mean by microparticle field, because particle physics in general is microscopic. There's a lot of really tiny particles, subatomic particles, microscopic or small, if you will. So if you're asking if gravitation has anything to do with the particles, then the answer would be yes. Gravitation has something to do with massive particle physics. Gravitation has something to do with anything with mass, especially, but also gravitation is the curvature of space-time. So gravitation actually, in general relativity, which is a correction to Newtonian mechanics. I was going to say Newtonian relativity, not relativity, but Newton's gravitation was giving us a theory for gravitation already. Einstein's gravitation is the general theory of relativity, and so it tells us that gravitation can be thought of as a curving of space-time by massive objects, and even light is affected by that. Particles are affected by that. Yes. I like this little starfish ring I have. It's looked It's going, thank you. Okay, so by the time people are talking